Hi guys, so in this video we're going to cover the section 2 review. So let's jump in. Number 1, and as a side note, the topic that the question goes to is listed, so you can always review those notes or homework. So solve the following and justify at each step. Okay. So I see that we have fractions. So the first thing I want to do is clear the fraction. And remember, you want to do a multiple of all of the denominators. So the denominators are 2 and 3. So a multiple of 2 and 3 would be 6. So I'm going to go ahead and multiply both sides of this equation by 6. Now remember that you have to multiply every single term. So I have to multiply 6 times this term, which again, it's easiest just to divide. So 6 divided by 2 is 3. And then multiply the numerator after. And then I need to multiply 6 times this term. And again, 6 divided by 3 would then be 2. And I'll multiply the numerator after. And 6 times this term, 1, which would just be 6. And 6 times this term, which 6 divided by 3 would be 2. And then I'll multiply the x after. So at this step, what I used was the multiplication property of equality. I multiplied 6 on both sides. So that would be M, E, E. Next, let's go ahead and distribute. So we're going to distribute 3. 3 times 4 is 12. 3 times negative x is negative 3x. 2 times 2x is 4x. On the right-hand side, 6, of course, is just 6. And 2 times x is 2x. I use the distributive property there to simplify. All right, next step, we want to combine like terms, right? So we're going to combine negative 3x plus 4x is 1x. So we're going to end up with 12 plus 1x. And on the right-hand side, we can't combine anything, so I'm just going to bring that down. And then we want to use the either addition property of equality or subtraction property of equality. You could view it as subtracting x or adding a negative x. And I also need to subtract 6. So I'm just going to do the both in one step. So we end up with 12 minus 6, which is 6, and 2x minus x, which is 1x. So this is our final answer. And again, you could either call that subtraction property of equality, or we could view it as adding a negative x and adding a negative 6. So you could also say addition property of equality. As a side note, you could have also used the division property of equality. If we divide by 1/6, it's the same thing. Multiplying a number is the same as dividing the reciprocal. Dividing a number is the same thing as multiplying the reciprocal. So same thing. So that's number 1. Let's move on to number 2. So on number 2, we want to identify the property. So notice we go from x plus y to y plus x. So in between we have addition. And notice that the order changed. So whenever order changed, that is the commutative property. So this would be the commutative property of addition, because in between was addition. Okay, next looking at this one. All right, now notice that the order of all 3 are the same, right? X, Y, Z, X, Y, Z. But the grouping has changed, so that's the associative property. And in between the grouping is multiplication. So this would be the associative property of multiplication. Okay, and then the last one over here, you see that this was x times this quantity and then xy plus xz. So as you could see, what happened was we distributed the multiplication of the x to all of the things that were inside. So that would be the distributive property. Alrighty. Let's move on to number 5. So on all of these, 5, 6, and 7, we're going to list all of these key features. Okay. Now, in order to do these easily, first I want to make a rough sketch of the graph. You always want to do that. Answering any key feature questions, positive, negative, increasing, decreasing, and behavior, all those things are much easier when you have a rough sketch of the graph. Now, these rough sketch is going to be very easy because these are just linear functions. And I do need to find the x and y intercepts anyway, so I'm going to just find those two and use those two as the 2 points for my line. So remember, for the x-intercept, we're going to set y to equal 0 and solve for x. So the y value set to 0, and then we're going to solve for the x value. So subtract 6 on both sides, we get -6 equals -3x, and then divide by -3 on both sides, -6 divided by -3 is +2. So the x-intercept is 2. Then we also want to find the y-intercept. So for the y-intercept, we kind of do the opposite, where we set x to equal 0 and we solve for y. Now, obviously here, this is in slope-intercept form, so I can already see that the y-intercept is 6. But even if I solved for that, right, y equals -3 times, we're going to make the x value 0 and solve for y. So y equals -3 times 0 is 0, 0 plus 6 is 6. So even if we solve for it, we would get the same thing. So I'm going to go ahead and make a rough sketch here. So I'm going to do a little coordinate plane, and I'm going to roughly graph the x-intercept, which is at 2, and the y-intercept, which is at 6. Those 2 points, and then I need to connect those with a line. I'm just going to use my line tool because it's going to make my life a little bit easier. Graphing with a pen on this computer is not that easy. So I'm going to cheat a little bit. I'm going to use the line tool. There we go. So now that I have the rough sketch, all of these other questions are much easier. Let's start with these bottom ones, and then we'll come back up for end behavior. So positive interval, right, is anywhere that the y value is positive, which would be above the x-axis. So as you notice, this piece right here that I just highlighted in yellow is above the x-axis. So where does that start? Well, if we look at the left side, right, we have an arrow here. So that starts at -infinity. And then where does that end? Well, we stop being above at the x-intercept. The x-intercept is where you go from positive y values to then negative y values, right? And the y value at this value of 2 is 0, right? That point is 2, 0. So the positive interval stops being positive at 2. Now, you don't want to use a bracket here. You want to use a parentheses, because the y value at 2 is not positive. So you cannot include 2 as a part of the positive interval, because it is not positive at 2. The y value at 2 is actually 0, okay? So same kind of idea for the negative interval. We start being negative at 2, not including 2. And then we continue to be negative all the way till arrow on the right, so positive infinity. Okay, moving on to the increasing interval. Now, increasing interval is any parts of the graph that go up from left to right. So clearly this entire function is going down. It has a negative slope, so it goes down from left to right. So there are no increasing parts, and the decreasing interval will be the entire function, -infinity to +infinity. Now let's move on to the end behavior. So remember, anytime that you're writing end behavior, you're always going to write as x approaches +infinity, the y value f of x approaches, and then you're going to fill in what. And then you also need to then say as x approaches -infinity, which would be on the left side, the y value f of x approaches, and then you're going to fill in what. So on the right side, if we look at the right side of the graph, we just have an arrow pointing down. So those y values, as I go more and more to the right, you're going to see that they go down more and more. So that goes to -infinity. On the left side of the graph, right, you can see that there's an arrow pointing up. which tells me that as the x values get smaller and smaller, right, as I go more left and more left and more left and more left, look at those y values are going up to positive infinity. Okay, let's do the next one, number 6. So the x-intercept, right, let's go ahead and just solve for that. X-intercept for y equals 0. If we set y to equal 0, we get 2x minus 3. Add 3 on both sides, we get 3 equals 2x. And then divide by 2 on both sides, we get x equals 3 over 2. Now, 3 over 2 as a decimal would be 1.5. That's going to help us when we are graphing. And then the y-intercept, I'm not going to solve for that. I can see it right here, right? The y-intercept is -3. Now, let's go ahead and make a quick rough sketch of this graph. So we have our x-intercept, which is at 1.5, or 3 over 2. And our y-intercept is actually at -3. So if I connect those two with a line, there's my rough sketch of this linear function. Now, the positive interval, right, the piece that is above the x-axis, notice it starts at 1.5 and then you continue on to the arrow to the right. That's the part that is above. So that starts at 1.5, not including 1.5 because the y value at 1.5 is 0. And then it goes all the way to the right till arrow. So it continues on the right hand side, it continues being a positive y value. So that positive interval will go to infinity. The negative interval is this piece on the bottom, right? So I'll highlight that in orange. This piece on the bottom has all negative y values. So that starts on the left hand side, right, on arrow on the left, so that would be -infinity. And then it goes all the way up to 1.5. All of these y values, negative y value, everything here is negative y value, all the way up to 1.5, but not including 1.5, because that value at 1.5 is actually 0, and 0 is neutral. Now, the increasing interval here, notice that the entire function is going up, right? So if you follow the graph from the left and you follow it to the right, you see that it goes up the entire time. So the increasing interval is -infinity to +infinity. The slope is positive, so it is increasing the entire time. And none of the graph goes down from left to right, so it has no decreasing interval. Let's go ahead now and do the end behavior. So as x approaches +infinity, we have to write what happens to the y value f of x. And as x approaches -infinity, what happens to the y value f of x. So on the right hand side, right, we see that arrow is pointing up. So as the x values increase, the y values also increase to +infinity. And then on the left hand side, as the x values decrease, the y values also decrease to -infinity. All right, let's move on to number 7. So I have here f of x equals 4, and remember that y equals 4 is a horizontal line on that number, right? So if we have a horizontal line on the y value of 4. Okay, so visually you can see here that this does not have an x-intercept, okay? There's none. And the y-intercept is 4. If you try to solve for the x-intercept, right, that's where we set the y value to equal 0. If we set the y value to equal 0, we get 0 equals 4. Okay? No, right? So there is no x-intercept. No, this will give you no solution, right, which means that there is no x-intercept. Now, looking at the positive interval, well, what piece of the graph is above the x-axis? Well, the entire thing is above the x-axis, right? So the positive interval would be the entire function from -infinity all the way to +infinity. The y value is always 4. Literally, the function is y value equals 4. That's it. So regardless of the input, the y value is 4. So the positive interval will be the entire function. And then the negative interval, there are no pieces that will have a negative y value, so that would be none. The increasing interval, there is no piece that goes up from left to right, so that is none. And there is, for the decreasing, no piece that goes down from left to right, so that's also none. Now, with the end behavior, remember we want to look at the right side and the left side separately. So as x approaches positive infinity, on the right side, where does the y value point? And as x approaches negative infinity, on the left-hand side, where does f of x approach? So looking at the y value, whether you're looking at it on the right-hand side, it's just 4, right? As I get more and more to the right, the y value is just 4. So as x approaches positive infinity, the y value goes to 4. And then same thing on the left-hand side, the y value goes to 4. All right, so that's number 7. Let's move on. All right, so moving on to 8, 9, and 10. Now, all of these are literal equations. Let's start with number 8. So we're solving for b. Remember, you want to focus on the variable that you are solving for. If I was solving for t, I would want to isolate t. T is almost by itself. It's not on this side of the equation at all. I would just need to divide by b, right? Or multiply 1 over b. But in this case, I'm solving for b. So I need to remove this fraction so that the numerator is no longer grouped, and I can then get the 7b to the left hand side to the other side that also has the term with b. You always want to make sure that all of the terms that have the variable that you're solving for go to the same side of the equation. You cannot solve for b here by just dividing t, because then you would have b on the other side. And you cannot define b with the equals on the other side having b as well. Okay, so the first order of business would be to get rid of the fraction, so I just can ungroup the numerator. So I end up with 2bt equals 7b minus 8. Now that I have that numerator out of the grouping from the fraction, I can subtract 7b on both sides to bring that term to the left-hand side with the other term, 2bt, which has the variable b, which is what I'm trying to solve for as well. Next order of business would be to consolidate the b's, because right now I have b's on multiple terms and I need to consolidate them. So I'm going to factor out b so that I can consolidate it. And factoring out, remember, is really just division. It's the opposite of distribution. So if I divide this term by b, I would get 2t. And if I divide this term by b, I would get -7. On the right-hand side, I'm just going to bring that down. Now that I have b multiplying to some quantity, right? I don't care what this is, it's in parentheses. I could just go ahead and divide that quantity. Anything divided by itself will cancel, and I'll get b on the left-hand side by itself. Now, of course, if I did that on the left-hand side, I have to do that on the right-hand side as well. So I do need to divide by 2t minus 7. So I have b equals -8 over 2t minus 7. Now, I can't leave my answer just like this because I do have a variable in the denominator of a fraction. So I need to determine what number that can be. Remember, you cannot divide by 0 in math, right? So the denominator cannot be 0. And if the denominator cannot be 0, that means that 2t minus 7 cannot be 0. So 2t minus 7 cannot be 0. So I need to figure out what value of t, what value for the variable would make this denominator 0, and that's the value that it can not be. So we're gonna actually just solve this almost like if it was an equation. So add 7 on both sides, we get 2t equals 7. And then divide by 2 on both sides, we get t equals 7 over 2. Now actually, t cannot equal 7 over 2, right? 2t minus 7 cannot equal 0. That's the restriction. So here, t cannot equal 7 over 2. All right, let's move on to number 9. All right, so on number 9, we're solving for y, okay? So we actually have 3 terms here. and only one term has y. So let's remove the term that does not have y. So I'm going to subtract 7z on both sides. So I get 2x minus 7z equals negative 3xy. Now, between negative 3x and y, all of these are multiplying together. So I can actually just divide by negative 3x to get rid of it. So I end up negative 3 divided by negative 3, of course, would be 1. X divided by x is 1. So I get 1 times y, which of course is just y. So I isolated y. So our answer would be 2x minus 7z over negative 3x. Now, of course, there is a variable in the denominator, so I do need to include that x value. Negative 3x cannot equal 0, so the x value cannot equal 0. Now, something else you could do is you could distribute the division of negative 3x to both terms at the top. So 2 divided by negative 3x, 2x divided by negative 3x would be negative 2/3 because x divided by x would cancel. And then negative 7z divided by negative 3x, negative divided by negative is a positive, so we would get 7z over 3x. So you could write it like this instead. Both of these are equivalents. Of course, you would still need to include that x cannot equal 0, but you could write it either way. You could either write it like this as one fraction altogether, or distribute the division and write it separately. Okay, moving right along to number 10. So on number 10, I'm solving for m. Now the issue is that m is in the denominator, so I'm going to need to move that to the numerator. The first thing I want to do actually is just get rid of all of the denominators. So I'm going to go ahead and multiply by m and a and d. That way I get rid of all three of them. So MAD times this fraction here would be MAD over m, and then MAD times 2 would be 2 times MAD over a, and then MAD times 1 would be MAD over d. Now m divided by m would cancel, a divided by a would cancel, and d divided by d would cancel. So we end up with AD plus 2MD equals MA. Now we are solving for m, so I need to bring, there are two terms that have the variable m on them. So I need to bring the term 2MD to the right to the other side with the other term with m as well. So I'm going to subtract 2MD to bring that to the right hand side, only because I'm solving for m and there are multiple terms with m in it. Now that I have all the terms with m on the same side, I can factor out m to consolidate the m's. So I'm going to factor out m, and again, remember that just means to divide. So MA divided by m would be a, 2MD divided by m would be 2D. And now m is multiplying to this entire quantity, so I could divide by that quantity to get rid of it. So I end up with my solution, m equals AD over a minus 2D. Of course, I do need to include the restriction here, and the restriction in this case would be that a and 2D, these two terms are subtracting, so they just can't equal each other, because if a is the same as 2 times whatever d is, then subtracting the 2, same thing, will end up being 0 in the denominator. So a cannot equal 2 times d. Alrighty, so let's move on to number 11. So on number 11, we want to write the equation for another line that would create a system with this line for each of these indicated solutions. So first, we want to do one solution and then infinitely many solutions and then no solution. So let's start with this first one. So one solution would mean that they have to have different slopes, right? So that they are, one is going one way, the other one is going another way, and then they would actually cross at one point. So any different slope will work. The y-intercept could be the same, it could be different. As long as the slope is anything other than 2, you're going to have one solution. Let's go ahead with 3. So I have y equals 3 times x, and again, with the slope, you could either make that, or I'm sorry, with the y-intercept, you could either leave that at 1. That would just mean that the solution would be the y-intercept, which would be 1. Or you could put anything else. I'm going to go ahead and do -7. All right, infinitely many solutions would be that it is the same exact line. Okay, now if it's the same exact line, you can actually write the same exact line as long as you do like a multiple of the line. So let's just multiply both sides by the same thing. Let's go ahead and multiply by 3. So 3y equals 2x times 3 would be 6x, and then 1 times 3 would be 3. So this line is actually the same exact line as this one. So together with this one, these two would give me infinitely many solutions. And then last one, we want no solution. No solution means that they have the same slope, but different y-intercept. So parallel lines, right? So we want the same exact slope, but a different y-intercept. So the y-intercept is 1. Anything other than 1 would work. So let's go with +5. Okay, so the same thing again, but now this equation grouped for one solution here, infinitely many solutions here, and then no solutions here. So one solution, again, is different slopes. Now, I don't know the slope of this one yet, so I'm going to just go ahead and solve for this, for y, to get it in slope-intercept form. That way I see what the slope is. So I'm going to subtract 3x on both sides, so we get 4y equals -3x plus 13. And then we can go ahead and divide 4. Of course, when we divide, we have to divide every single term. So we get -3/4x plus 13/4. So the slope is -3/4. So any slope other than -3/4 will give me one solution. So let's pick a slope of 2. And the y-intercept could be anything here. You can make it the same thing or something else. I'm just going to leave it y-intercept at 0, so nothing there. Infinitely many solution has to be the same exact line. So again, any multiple of the line will work. Let me just multiply this by -2 this time. So -6x minus, 4y times -2 would be -8y. And then 13 times -2 would be -26. So again, these two equations are the same. So if we grouped these two together in a system, right, not the middle one here, but these two together in a system, then I would have infinitely many solutions. So last one, no solution. Again, you would need the same slope, but a different y-intercept. So the slope has to be -3/4. And then the y-intercept, you could put anything. I'm going to go with 2. All right. So that is number 11. Let's move on to number 12. We need to solve the system. And I noticed that one of my equations in this system, it has fractions. So the first thing I want to do is get rid of those fractions. So I'm going to go ahead and multiply by a least common multiple, which is 6. Any multiple will work. The least one is the best because your numbers are going to be the smallest, but any multiple of the denominator. So we're going to end up with 2x plus 3y equals 3 times 6, which is 18. So now I have these two equations, boom, up here, and then boom, this one on the bottom. I do need one of the coefficients to be the same because I want to solve by elimination. You could do substitution, but none of these have a coefficient of 1, so not a good idea to do by substitution because you would have to divide the coefficient and then that will give you fractions, and we probably don't want to do that. So I'm going to go ahead and multiply this equation by 2, and I'm going to multiply this equation by 7. That way the coefficient of x is 14 on both. So I'm going to rewrite that system right down here. On the top equation, you get 14x minus 14y equals negative 14. And then on the bottom equation, you get 14x plus 21y equals 7 times 18, which is 126. Okay, so now we can go ahead and subtract these two equations together, because 14 plus 14 will give me 28, and I want to eliminate 14x, so I'm going to subtract them. And remember, you do need to distribute the negative, so negative 14 minus 21 would be negative 35y, and negative 14 minus 126 would be negative 140. Then we would divide negative 35 on both sides, and that would give us y equals 4. Now that's half of the solution. I need to now also find the y value of this system, or the x value of the system, using the y value. So I'm going to go ahead and plug in this y value just right into this equation right here. So 2 times the x value plus 3 times the y value, which I just found was 4, equals 18. And now I just need to solve for x. So 3 times 4 is 12. And subtract 12 on both sides, we get 2x equals 6. Divide by 2 on both sides, we get x equals 3. So the solution is 3, 4. As an ordered pair, you can write that as well, right? Let me just box that a little better. There we go. As an ordered pair, that would be 3, 4. So you could write it as an ordered pair or write them separately like that. Let's go ahead and move on to number 13. So everything is lined up here, so I think I want to solve this with elimination. And I could very easily make this to a negative or a 4 by multiplying by 2. So that will give me 4x plus 10y equals 12. And then now I can use elimination and add these two together. Negative 4x plus 4x would be 0. Negative 10y plus 10y would also be 0, so I end up with 0 on the left-hand side. And then negative 10 plus 12 gives me 2. So the variable canceled, and 0, does that equal 2? No. So this is no solution. There are no values of x and y that would make that both of the equations true. Okay, moving on to number 14. Now, y equals, boom, we already have y isolated, so this one's easiest to solve with substitution. Y equals 2x plus 3, so I could take 2x plus 3 and substitute it in for y here. So negative 6x plus 3 times the y value equals 9, and the y value equals 2x plus 3. So now I could just go ahead and simplify and solve for x. So we end up with negative 6x, and then 3 times 2x is 6x, 3 times 3 is 9, and then I'm going to bring down the equal sign and bring down the 9. Negative 6x plus 6x cancels, and we get 9 equals 9. Okay, so the variable canceled here, but we get a true statement. 9 does equal 9. So this means we have infinitely many solutions, or you can write all real numbers. All right. Moving right along, let's move on to number 15. So on number 15, we are solving this system, and we have f of x equals 2x and g of x equals 6x, 6 minus x. Now, this is just the y value, right? Y equals this, y equals this. So you could set the y values equal to each other, okay? Or you could view it as plugging in this y value into this y value. Right? So we end up with 2x equals 6 minus x. Add x on both sides, we get 3x equals 6. Divide by 3 on both sides, we get x equals 2. Okay, great. We're halfway done. We now need to find the y value. So I could either plug that into the bottom one or the top one. It really doesn't matter. Let me plug it into the top one. Y equals 2 times the x value, which we just found was 2. So y equals 4. Okay, that was easy. Let's move on to number 16. Find the inverse of the function. Okay, so for the inverse, remember the inverse notation looks like this. And to find the inverse, you switch the x and the y. So in the equation, I'm going to switch this y value with x, and I'm going to switch this x value with y. And then you need to solve for y. So I need to add 8 on both sides. So we get x plus 8 equals 3y. And then we need to divide by 3 on both sides. Now, just like multiplying, I have to divide every single term. So I end up with 1/3 x plus 8 over 3. And that equals the y value. But remember, this is the inverse, right? So I can write it with inverse notation. So this is the inverse of f. Okie dokie. Let's move on to number 17. So given the tabular representation of f of x, find the algebraic representation of the inverse of f. So, all right. Now, normally what I do is I look at the table, because notice that we do have the y-intercept. So it's very easy to write the equation for this one, because I do need the equation for the inverse. So I could write very easily the equation for the original function with this table. However, even if I switch the table, right, if I switch the x and the y values, I will have the y-intercept of the inverse as well, because I have the x-intercept of the inverse and or of the original function. So remember, the inverse is the flipped around version of the original function. So for the y-intercept of the original function, that becomes the x-intercept of the inverse function, and vice versa. The x-intercept of the original function becomes the y-intercept of the inverse function. So I have the x-intercept here, which would mean that is the y-intercept of the inverse. So I could write the equation for the original and then switch the x and the y and solve for the inverse equation that way. Or I could make the table of the inverse and use the y-intercept and the slope from the table. So I'm going to show you how to do both ways. Let's start with method 1. Method 1, let's do where we switch the table first. That one doesn't look very good. All right. So method 1. Okay, let's switch around and do the table first. So this is the table for the inverse function. So we have 9, -2, 6, 0, 3, 2, and 0, 4. So I can't just call this my answer, because they didn't ask for the tabular representation of the inverse. They asked me for the algebraic representation of the inverse. So they're asking me for the equation. So with the equation, I do have the y-intercept right here. So the y-intercept is 4. Now I just need to find the slope. So the slope, right, the change of the y value, -2, we would add 2, right, to get to 0. And then from 9 to 6, we would subtract 3. So the slope is change of the output, which is 2, over change of the input, which is -3. So the slope is -2/3. So the inverse function I already have is -2/3 x plus 4. So that's method 1. Really easy, because we already had the x-intercept of the original, which would be the y-intercept of the inverse function. Now, method 2 is doing the equation of the original first. So with the original, the y-intercept is right here. The y-intercept is 6. And then the slope, if we do the change of the y value, is -3. And the change of the x value is +2. So the slope would be change of the y value -3 over change of the x value +2. So the equation of the original function would be -3 over 2x plus 6. Now, to find the inverse, I could now solve by switching the x and the y. So that's the other way that we could find the inverse here. We're going to switch. The y value becomes x, and the x value becomes y. Now, we would subtract 6 on both sides, because we need to solve for y. And then we need to multiply by the reciprocal, -2/3, to cancel out this fraction. Now, of course, I do need to multiply every single term. So I end up with -2/3 x, and then -2 times -6 would be +12. 12 divided by 3 would be +4. And that is what y equals, which this is the inverse of f. You can see that we end up with the same answer either way that we do it. Do not forget to distribute and multiply every single term. When you multiply both sides, if you're dividing, same thing, you have to divide every single term. All right, let's move on. Number 18. All right, on number 18, we're solving by graphing. So let's go ahead and isolate y on the top equation just to get that in slope-intercept form. It becomes easier to graph that way. So I end up subtracting 2x on both sides. So I end up with -y equals -2x minus 8. And then multiply everything by a -1. We get y equals +2x plus 8. Okay, so now I can graph both of them. Let me graph that top one I just found, y-intercept of 8, and then a slope of 2/1. So rise 2, run 1. We could also go the other way, down 2, left 1. We only really need 2 points to make a line, so that's good enough. Let me go ahead and connect those two with a line. Perfect. And then add arrows on my sides. All right. And then now let me go ahead and graph the second one. I'm going to graph that one in blue. So y-intercept of 2. And then the slope is -4/1. So that's -4. So instead of rising, I'm going to drop 4. And then run 1. Drop 4, run 1. I could go the reverse order as well. Rise 4, left 1. And of course, then connect those with a line. Now, this is not the solution to the system, right? This is just the method that I use to solve the system. The solution is the intersection point where the x and the y value is the same for both equations, right? So the solution would be -1, 6. All right. Let's move on to number 19. Now, number 19, we're solving the system of inequalities. So I need to go ahead and graph both of these inequalities. I'm going to isolate y by subtracting x on both sides here. Then with y is less than -x plus 2. Now, I didn't need to flip around the inequality symbol, but just keep in mind that with inequalities, if you divide or multiply by a negative, you do need to flip the inequality. And your y value has to be on the left-hand side in order for you to interpret the inequality symbol correctly. So let me go ahead and graph the top one. So we have a y-intercept of 2. And then the slope is -1/1. So I'm going to drop 1 to the right one. And I'm going to connect those two with a line. Hopefully this line will be looking good. I'm going to try my best. It's pretty good. Now, the one thing that I do need is to look at the inequality symbol. Notice that this is less than, right? It's not less than or equal to. So we are not including this line as a part of the solution. So this line has to be dashed, not solid. Let me make that a little bit bolder so you can see that it's dashed, not solid. And I do need a shade because it's all of the y values that are less than. So the y values are lesser on the bottom, right? Now, normally I would shade that entire section, but this is a system. So I do need to first be careful and just make little arrows to note to myself that that should be shaded on the bottom, but I don't want to shade yet because the solution to the system is going to be just the one area that overlaps and is shaded by all of the inequalities in the system. So I need to graph the second one to be able to see that area. Let's go ahead and graph the second one in green. So the y-intercept is -5. And then the slope is 2. So it's 2 over 1. So rise 2, run 1. And I'm going to connect those two with a line. And in this case, we do keep this line solid. Okay, I'm still going to make it bold just so it matches the other one. A little OCD. So I am going to make it bold. But we are going to leave that line solid. Why? Because look at the inequality for that second line. The inequality is greater than or equal to. So we are including that line as a part of the solution. Okay. And then we do need a shade on the top. So which area, which one of these 4 areas, this one, this one, this one, or this one, is shaded by both? Well, the red one is shaded on the bottom, so it would shade all of this. And then the green one is shaded on the top, so we would shade all of this. So the area that's shaded twice is this left area right here. So that's what I'm going to shade in for the solution to the system. And you could even pop an S onto that bad boy, just to say that that is the solution area. My shading went a little bit to the right here, so I do want to erase that. The solution area is right here. All right, let's move on to number 20. All right, so number 20, we have 3 parts, and what we're doing is we're determining if it's even, odd, or neither, and we are doing that algebraically, okay? Or we're justifying it algebraically. We can figure it out in any way we want, but we do need to justify algebraically why. So looking at this first one, right, we don't have any like inclination of what kind of function this is yet, but we could still find out whether this is even, odd, or neither algebraically. So remember to do that. We're going to test if h of x, the original function, equals h of -x. If this is true, then it is even. If it's not even, then we're going to check if it's odd. Okay, and how we check if it's odd is we check that function that we just found, h of -x, we check if that equals -h of x. If this is true, then it is odd. Okay, so let's go ahead and do that. Let's first find h of -x so that we compare that with the original to see if it's true. So h of -x, we're going to plug in -x into the input for x. And then we're going to simplify. So -x squared will be -x times -x, which would be +x squared. And then -x would just be -x. And when I compare that with the original h of x, you can see that that is not the same. So it's not even. Now let's go find if it's odd. So with odd, I need to take the entire function and multiply it by a negative. So I'm going to take this entire function and multiply it by a negative. And I'm just going to go ahead and distribute that to the bottom just so it matches the bottom being negative on this one. And when we compare, you can see that these two are in fact exactly the same. So this one is odd. All right. So looking at part B is linear, right? Y equals something times x. The power is 1, so this is a linear function. So notice this is a linear function with the y-intercept of 0, right? Y-intercept of 0, right, would mean that it is odd. So just by knowing that, I know that this function is odd. However, okay, I do need to justify that algebraically. So let's show. G of -x would be 3 times -x, which would be -3x. Notice that G of -x does not equal G of x. Now let's go ahead and find negative g of x. We take the entire function, make it negative. We get negative times 3x, which would be negative 3x. And when we compare negative g of x with g of negative x, we see that these two are exactly the same. So it is odd. All right, and let's do part C last. So notice that's y equals 0. Y equals 8. So that means that the slope equals 0. And if the slope is 0, you have a horizontal line, which would be even because it will be symmetrical about the y-axis. So I already know it's even, but they did ask me to justify that algebraically. So let's go ahead and show that, right? F of negative x. Now on the right-hand side, we just have 8. So that would just be 8. And notice that f of negative x is equal to f of x. So that is, in fact, even. Because these two are equal. There's no variable there, so there was nowhere for me to actually plug in negative x. So regardless of the input, whether it's negative x or anything else, the output is just 8. So the output stays the same, and therefore it is even. Okay. Moving on to number 21. So this one is a 3 by 3. And you could do this by substitution, but I am going to do this with elimination. Okay, I am looking at the coefficient of x, and I see that two of the coefficients of x are already the same. So I'm going to go ahead and group those two together. So I'm going to group x plus 2y minus 2z equals negative 15 with x minus 4y plus z equals 18. And then I need to group the middle one with one other equation. Obviously, I'll have to double up and either use the top one again or use the bottom one again. I'm going to just go ahead and use the top one. I do need to cancel out x on the same one. So I would very easily just multiply this by 2. So I'm going to group these two together. So I'm going to multiply this by 2 as I write it down to group it. So 2 times x plus 4 times y minus 4 times z equals negative 30. And again, I just multiply that first equation by 2. That way now when I group it with the middle equation, which is 2x plus y minus 5z equals negative 21, the coefficient is the same. Because again, remember, with elimination, you do need to cancel out the same variable on both groupings. So now I can go ahead and subtract these two equations together. That'll cancel out x. And I could subtract these two equations together. That'll cancel out x. So now let's just go ahead and simplify. So 2y minus negative 4y would be 6y. Negative 2z minus 1z would be negative 3z. And negative 15 minus 18 would be negative 33. Okay, and then moving on to this one, 4y minus 1y would be 3y. And negative 4z minus negative 5z would be negative 4z plus 5z, which would be plus 1z. And then negative 30 minus negative 21 would be negative 30 plus 21, which would be negative 9. Okay, now I need to put these two together now in a system of its own. Now I have two equations with two variables, and I could solve this like any other regular system that I have before. Okay, so obviously the easiest here would probably be to do elimination. So I'm just going to go ahead and multiply this equation by 2. That way the coefficient of y will be the same. So that gives me 6y plus 2z equals negative 18. And then I'm going to cross that out just so I don't mix it up. So now I need to subtract these two equations together. Remember to distribute the negative. So 6 minus 6 would be nothing. Negative 3 minus 2 would be negative 5z. And negative 13 minus negative 18 would be negative 33 minus 18 would be negative 33 plus 18, which is 33 minus 8. So that would be negative 15. And then divide by negative 5 on both sides, we get z equals 3. Okay. So we're a third of the way there. Now we need to find the y value we can find by plugging in z right there or there, either one of the two. I'm just choosing to go with this one. So 3 times y plus z, 1 times z, which is 3, equals -9. Subtract 3 on both sides, we get 3y equals -12. And then divide by 3 on both sides, we get y equals -4. All right, now we have z and y. We just need to find x. So I'm going to take both z and y and plug it into one of the original equations. I'm going to pick this bottom one to find x. So x minus 4 times the y value, which we already found was -4, plus the z value, which we found was 3, equals 18. -4 times -4 is +16, so 16 plus 3 equals 18. 16 plus 3 is 19. X plus 19 equals 18. And then subtract 19 on both sides, we get x equals -1. So you could leave it like that, or you could write it as a coordinate. As a coordinate, remember always to write it alphabetical order. So you would write x first, then y, and then z. So this would be the solution as an ordered pair. All right, let's move on to number 22. Okay, so number 22, we're going to graph the solution to the system. So this is another system. It's just now we have more than 2 inequalities. We have 3 inequalities. So let's go ahead and isolate y on each of them. So for the first one, we would add x on both sides. So we end up with y is less than x plus 2. On the second one, we need to add 1 on both sides. So we end up with y is greater than or equal to 2x plus 1. And then on the last one, we need to divide every term by 2. So we end up with y is less than or equal to -2x minus 1. So let's go ahead and graph the first one, y-intercept of 2. Slope of 1 over 1. So rise 1 over 1. Connect those two with a line. And this line has to be dashed because the inequality is less than. So I'm going to change this to a dash line. And it is less than, so we would shade below the line. Okay, moving on to the middle one in green. The y-intercept is 1. And the slope is rise 2, run 1. And I'm going to connect those with a line. Now this line is greater than or equal to, so it will stay solid, but it is greater than, so I should shade above for this particular line. And then the last line, the last inequality has a y-intercept of -2. I'm sorry, -1. And the slope is -2, so down 2 to the right 1. And connect those with a line. And the inequality here is less than or equal to, so this will stay solid. And it is less than, so it should be shaded on the bottom. So which area is shaded by all 3 lines? Well, the red one is shaded on the bottom here, right? The green one is shaded on the top. So that would leave this middle area shaded by the green and the red. And the blue line cancels out this area right here because the blue line has to be shaded on the bottom of those. So the area, the solution area, would be not this entire triangle, but just up to this blue line right here. And we can pop an S on there for the solution area. Okay. Let's move on to 23. So on 23, we need to graph the inverse of this equation. Okay, so first let's go ahead and find the equation of the inverse. So let's go ahead and switch the x and the y. And then I need to solve for y, so I need to get rid of the 1/3. So let me multiply by the reciprocal of 1/3, 3. And of course, if I multiply, I have to multiply every term. So I end up with 3x plus 6 equals y. Because remember, we have to distribute that to every term. So 3 times x, 3x, 3 times 2, 6. So the inverse function, actually there's no function notation here. So the inverse is y equals 3x plus 6. So y-intercept of 6, and then slope, rise 3, run 1. And then connect those with line. And that is the line of the inverse. Off by a little bit here. Let me go ahead and move it over just a tad. There we go. That's a little more exact. That's good. All right, so that is the inverse graph. Number 24. Each morning, Darnell does a combination of aerobics and stretching exercises. The exercises burn different amounts of calories per minute. The system represents the time Darnell exercises and the amount of calories burned. In the system, X represents the number of minutes Darnell spends doing aerobics, and Y represents the number of minutes he spends stretching. Use the system to answer the following questions. Okay, how many minutes does Darnell spend exercising? So that means exercising in total, right? So notice that the total of number of minutes spent aerobics plus minutes stretching, total exercising is 60 minutes. How many calories per minute does Darnell burn? Well, we're multiplying, right? How many calories burning per minute of aerobics is X, and then multiplying the number of calories times per minute of stretching, and that equals the total calories that he burned. But the question is how many calories per minute does he spend doing aerobics? So that would be the 15. And then how many calories does he burn stretching? So that would be the other coefficient, which is 5. And then how many total calories does he burn? That would be 500. Now, using elimination, solve the system. So we don't want to do elimination here. So I'm going to go ahead and multiply the top equation by 5, just so the coefficient of y is the same. So I end up with 5x plus 5y equals 5 times 60, which is 300. And then the bottom equation, of course, stays the same. And I'm going to subtract these two equations so that the y term cancels. 5 minus 15 is negative 10x, and 300 minus 500 is negative 200. Divide by negative 10 on both sides, we get x equals 20. Now, if x equals 20 and x plus y, actually x is 20, so let me fill that in. So x plus y equals 60. That means that y equals 40. So he spends 40 minutes doing stretches and 20 minutes doing aerobics. All right, let's move on to number 25. So 25, we need to write the system of inequalities that is graphed. So it doesn't matter which line you start with. I'm going to go ahead and just start with the horizontal one because that's easy. Or any horizontal line is y equals whatever y value we cross on the y-axis. So this would be the line if this was a linear equation, y equals 3. Now, of course, this is an inequality. It is shaded on the bottom, and it is dashed. So this would be the inequality. Y is less than 3 because we shade below, and it is dashed, so no or equal to. The next line, let's go ahead and do the equation for this one. If it was just a regular old line, the y-intercept is 1 and the slope is down 1 over 1. So the y-intercept is 1 and the slope is negative 1. So this as an equation would be y equals negative x plus 1. Now, this is, of course, not an equation. It's an inequality. It is shaded on the bottom, and it is a solid line. So this would be y is less than or equal to, because it is solid, negative x plus 1. So that's the system. Okay, moving on to number 26. Danny has invested $5,000 in 2 accounts, one saving account paying 5% interest and the other a bond account paying 8%. If the annual interest from the 2 investments was $400, write a system to model the situation. Okay, so let's write a system. We're going to have to write our variables, x and y. I'm going to have x represent the 5% account, the amount of money that I put into the 5% account, and I'm going to have y represent the amount of money that I put into the 8% account. So first, the total amount of money, he said that he invested $5,000. So how much ever I put in the 5% plus how much ever amount of money I put in the 8% account will equal the total invested, which was $5,000. Apart from that, I do know that he made interest from these accounts, and that's how much money he made in interest. Now, how much money he made in the 5% account would be the 5%, of course, as a decimal, multiplied how much he ever put into that particular account. And then to that, we're going to add the amount of money that he made from the 8% account, which would be the 8% interest times how much ever he put into that 8% account. And that interest from the 8% account plus the interest from the 5% account equals the total interest that he made, which is $400. So this is my system. All right, let's move on to 27. So on 27, the junior and senior classes are raising money for their prom. The junior class purchased 400 caramel apples for $500, and they plan to sell caramel apples. I'm struggling with saying caramel or caramel, however you say it, for $5 each. So the senior class purchased 600 donuts for $400, and they plan to sell the donuts for $3 each. Okay, so we have juniors, we have seniors, we have juniors, and we have seniors. So we need to write the system to represent the situation, and we need to determine the domain and the range. So first, let's go ahead and write the system. Okay, so I'm going to have x represent the number of items that they sell. Now, depending on, juniors or seniors, I'm going to just have x represent both. And then I'm actually, I want to use f of x to represent the amount of money that the junior class makes, so the junior profit. And g of x represent the profit from the seniors, so the seniors profit. Of course, I could have just gone with y and said that's profit, but I want to be specific. F of x will represent the juniors and g of x will represent seniors. That'll make when I do the domain and range easier to label over here. So, okay, so for the f of x function, right, how much profit the juniors make, that'll be calculated from how much money they make from selling minus the amount that they had to spend for purchasing the items. So they will make, right, the juniors are making $5 per each thing that they sell. So they're going to make 5 times how many ever things that they sell. But to their profit, they need to subtract how much they spent on caramel apples, which is $500. Now for the seniors, this is a little bit different, but kind of the same idea, right? So for the seniors, they're selling their donuts for $3 each. So the amount of money that they make from selling donuts is 3 times how many ever they sell. And then they purchase their items for $400. So their profit needs to be subtracted by 400. Okay, so that is the system right there. So that's a part of the answer. They also asked me in this problem to find the domain and the range. So let's go ahead and do that. First, let's go ahead and write the domain and range for f of x. Okay, so for f of x, the domain, remember the domain is what are the x values that are possible for the function. So for f of x, the juniors, the input is the number of items sold, right? And the output is the amount of money that they make. So the amount of items that they can sell would be either no items at all sold, which is very, very bad, or they could sell at most how much items they purchase. They purchased 400 items, so they could sell up to the 400 items that they purchase. They can't sell more than what they had already purchased, right? If you bought 10 t-shirts, you can't sell more than 10 t-shirts, so you don't have more than 10 t-shirts to sell. So that's, logical. And then the range is the output, right? What are the possible outputs? How much money can they make? Well, the smallest amount of money that they make is if they sold 0 items, right? If they sell 0 items, right? If we sell 0 items, f of 0 would be 5 times 0 minus 500, which 5 times 0 is 0, 0 minus 500 is negative 500. So they could be out $500. If they end up selling nothing, then they spend $500 on those caramel apples and they are under. They did not make any money at all. Now, the max amount of money that they could sell would be if they sold all of their items, right? You completely sell out of all of your items. That would be the most amount of money. So if they sold all 400 items, what would their profit be? Well, we could calculate it using the equation, right? 5 times the 400 minus 500. Now, actually, that looks like a weird 4. Let me fix that. So 5 times 400 is 2,000, and then 2,000 minus 500 is 1,500. So they could make $1,500, and that's the most that they can make. So this is the domain and the range for f of x. And I am using brackets here because it is inclusive of 0 and 400, and it is inclusive of negative 500 and 1,500, right? Now, specifically speaking, the interval here from 0 to 400 is integers only, so it is important to write that. Because you can't sell, like, give me a half of a caramel, right? Apple. You don't want to sell a half of a caramel apple. So let me just have my box include that. I got a little ahead of myself putting the circle around that before I was ready. But the money does vary. Of course, now any amount of whole number that you multiply to the $5 will still give you a whole number. But in theory, money can be like in cents or whatever, so you can have other than whole numbers. Let's go ahead and write the domain and range for g of x. So for the domain, same kind of idea, right? The smallest amount of things that we could sell would be 0. The highest amount of things that we could sell would be up to the $600, 600 donuts that we purchased. Now for the range, again, the smallest amount of money that they could make is if they sold 0 donuts, right? So g of 0, excuse me, not f of 0, g of 0, right, for the seniors. If they sold 0 donuts, then they would be out $400. 3 times 0 is 0. 0 minus 400 is negative 400. So they would be out $400 if they sold no donuts at all whatsoever. And the most amount of money that they could make is if they sold all 600 donuts, right? So 3 times 600 minus 400 will give me what profit? Now 3 times 600 minus 400 is 1,400. 3 times 600 will be 1,800. 1,800 minus 400 is 1,400. So they could make up to $1,400. And again, this would be integers only. And that is the domain and range for g of x. All right, so that's number 27. Let's move on to number 28. Okay, so the yoga instructor spent $1,925 on 200 items for the year's Love Your Body Week. He purchased yoga mats for $12.50, yoga towels for $8, and carrying cases for $10. He purchased twice as many towels and mats. Write a system. Okay, so we actually have 3 things at play here, right? We have X, that's going to be the number of yoga mats that were purchased. Y would be the amount of yoga towels that were purchased. And I'm going to have Z be representing the amount of carrying cases that were purchased. So this system here, right, we have one equation for how many things we bought total. We bought a total of 200 items. So the yoga mats that I purchased plus all of the yoga towels that I purchased plus the total amount of carrying cases that I purchased, That'll give me the total amount of total items that I purchased, which is $200. I'm sorry, 200 items. And then the second equation will be how much money I spent. I spent a total of $19.25, right? Now, that's going to be calculated with how much money I spent on yoga mats, which were $12.50 each. So $12.50 times the amount of yoga mats that I purchased. And then to that, I need to add how much I spent on yoga towels, which I purchased those for $8 each. And then to that, I need to add how much I spent on carrying cases, which I spent $10 each. And that equals the total amount of money I spent, which is $1,925. All right, and then the last equation actually comes from this second to last sentence. He purchased twice as many towels as mats. Now let's break this down, right? He purchased twice as many towels as mats. So what did he purchase more of? He purchased more towels. So the amount of towels, Y, equals twice, 2 times the amount of mats, which is X. So the equation there would be Y equals 2X because he purchased the amount of towels equals 2 times the amount of mats. All right, let's move on to the last couple problems. Okay, so 429. Blank wants, so I believe this lady's name was Shani. So Shani wants to work a part-time job at Free Spirit Writing Academy in Wellington. She would make $9.50 an hour for exercising horses and $13.75 an hour for cleaning stalls. Shani's parents told her that she cannot work more than 20 hours a week, and Shani would like to learn at least $165 a week. So write a system to represent the situation. So notice that we're using words like more than and at least, right? So this is going to be a system of inequalities. So she needs to make a total of at least $165. So the amount of money that she makes needs to be at least, which means more than or exactly $165. Now that is going to be calculated by taking how much she would make exercising horses, which would be $9.50 times how much ever hours she works exercising horses, which is X, and then add that with $13.75. Oops, I'm running out of space here, so I'm gonna move this to the right. $0.75 times how many ever hours she spends cleaning stalls. So X represents, I forgot to write that down, right? X represents how many hours she spends exercising horses. And Y represents how many hours she spends cleaning the stalls. So the other thing that they told us was the amount of hours, right? Her parents want her to work cannot work more than 20 hours a week. So she can work no more than 20 hours a week, which means that she can only work less than 20 hours or exactly 20 hours. And that would be for the total amount of hours, how many ever hours she spends cleaning, exercising the horses, plus how many ever hours she spends cleaning the stalls. So the total amount of hours for a week cannot be more than 20. She cannot work more than that amount, which means she can work that amount or less. All right, so that's the inequality. Okay, and last problem, number 30. So the altitude at which we oil an egg affects how long it takes for the egg to achieve hardness. Okay, great. I think this must be boil. Couple typos on these last questions. Anyway, the first sentence doesn't even matter anyway. It's just like a little background story. It takes 203 seconds to boil a perfect egg at the lowest place possible. The edge of the Dead Sea, which has an altitude of, boom, right there. The highest place possible is the summit, Mountain Everest, which has an altitude of, boom, right there. And it takes 209 to boil the perfect egg there. So T of A models the time in seconds. So T of A, which is the output, correct? That is the Y value, models the time that it takes to boil a perfect egg at an altitude A, which is in meters. So the input A, which is the input, is meters, which is measuring the altitude. So the input measures the altitude and the output measures the time. So the time is in seconds and the altitude is in meters. Okay, great. So the question is, what is the appropriate domain and range for the situation? Okay, well, domain is what are your possible inputs? Now the input is the meters, right? The altitude. So the smallest altitude is given to you right in the question, right? The smallest altitude is negative 1371 feet. And the highest altitude, the highest place possible for this boiling egg, is 29,029. Now the range are the possible values of the output, which is time, which is measured in seconds. So we have the smallest amount of time would be for boiling it at, where am I? So it takes 209 seconds to boil a perfect egg at the highest altitude, but it takes, where is it? Oh, there it is, 203 seconds to boil a perfect egg at the lowest temperature. So the smallest amount of time for this equation would be 203, and then the largest would be 209. And that is the domain and range for this situation. All right, so that is the review. I hope it was helpful, and I will see you guys later.